So the topic for the panel discussion is life cycle cost of a steel building. So it's a pretty interesting topic. Before we get going on that, what I think we should do is kind of quickly introduce all the panelists. Each one should do it, and then doing that, just tell everybody what your connection with steel is. So just, what your experience has been with steel. Let's limit it to about a minute or 2 minutes. So with that, my name is ABHIJIT SHAH. I'm the managing director of a company called Walter P. Moore, and we are a structural engineering and infrastructural engineering firm. I've been with them for about 20 years and got the opportunity to design a lot of steel structures, including mid to high-rise buildings, residential, commercial, a lot of long-span structures like stadiums, arenas, convention centers, and airport terminal buildings. So that's about it. I guess we have a pretty diverse panel here. On the right, we have three architects. On the left of me, we have a structural engineer, and then 2 from the materials side. So why don't we start with you, Vivek, or start from the end. So Shukanta, go ahead and get us started.
Hello. Shukanta BASU. I'm a partner of Utopian Associates. We are practicing architects since 2007. Association for Steel. Association with Steel, I think that needs no introduction because every architect is some way or the other associated with steel, with whatever designs we do and whatever forms we dream of. Sometimes it becomes impossible without steel. So I think we can go ahead with the discussion and slowly we can reveal, what are the things which we are facing and how we can actually develop and how we can contribute to the community.
Hi, hello everyone. ADITYA GOSWAMI, Architectonic Services. We are based out of KOLKATA and New Delhi. And what Abhijit said, connection with steel, and elaborating on what Shukanta said, that every architect is connected to steel. I would just like to add to this that as a practicing architect, what we are trying to do is, a majority of architects across the country, across our country, we actually work towards hiding the steel in the building. In our case, what we've been recently trying to do is we are trying to make steel visible and celebrate steel. Just as a prelude to the tea, we were having a discussion where, wherever we are doing hospitality or large housing projects, the lifestyle part of the project, like a club or maybe a banquet of a hospitality project, that we are trying to make in steel so that it actually interacts with the mass in a way, because in India, I think the majority of people are still not habituated to seeing steel as a part of the facade, so to say. And more as we elaborate, I think, Vivek.
Okay. This works. It's working. So namaskar, and I'm Vivek. We have been happily celebrating steel since 2007 onwards. And I can tell you that in the various disciplines, architecture, landscape, interiors, we have evolved that the steel is not just one component where you can look at us in terms of building. It's a material for imagination augmentation, to augment your imaginative quality. So we have seen our steel becoming very integral part even in interiors, space, geometric augmentations, introducing spaces, managing spaces. In landscape, managing environmental, the forces all around. So we see steel going from the building inside the interior spaces and also in landscape and outside. So that's what we have seen our evolution. So what I can tell you is over the last 3 to 4 years, our firm has started working on such uses of steel where we can make it all modular in terms of both fabrication inside the building, outside the building. So the entire approach, it was just not a steel, but how to use steel. So today's the topic is quite interesting, and the topic talks about the life cycle cost analysis. So LCCA. I wish that the forum should be open for question and interactions. And
Absolutely.
that's what the moderator just made it very clear. So we all welcome you guys, and please be very vocal about being a little controversial. It's okay, because we need to get the sludge out of our mind that steel is not just a component, but it is a language, and it is also a generic material for forming anything. It's just not a material to be employed as a reinforcement or a strengthening. It's much more beyond that. We have been also, in the last, I just want to say that recently we have tried to use other ways in which steel can do, and we try to work it out in terms of adaptive reuse, in terms of heritage reinstations. So there we have seen that steel plays a very important role, especially with the buildings that we have. Old buildings, India is full of buildings, old buildings, heritage buildings, buildings that we want to keep as a culture. And believe me, when you look back into Calcutta and you go back into the oldest building, it's not a new material, you will find it in steel. Driving through this lane, if you just walk into any of the driving lane, you will see how well the steel was employed even 80 years earlier in Calcutta. So this is where I want to make you feel proud that you are in a city which has consumed and employed steel creatively over the last 80 to 100 years and have a strong legacy in design.
And of course, on the bridge.
No doubt.
Yeah. So I guess we'll go to our left now.
Good evening, ladies and gentlemen. I am UTPAL SANTRA, Director, MN Consultants Private Limited. I am a structural engineering practicing over 30 years in Calcutta. My connect to the steel is long back. I think everybody has seen that building in the Ultadanga. That's a VSNL building. I think I don't know many of you is aware of that. It's a 14-storied building, and it's a steel building, has been constructed that long. With a concrete core and all steel columns and steel beams and prefabricated slab panels. Very, very smart building and way ahead of its time. So, and as Vivek said, it's if you go into the history of the whole Calcutta and as well as the history of steel in India is long. In fact, we used only steel at some point of time. Concrete came much later. Probably in India, it's 1960s or something like that. The concrete came 50s and 60s. But prior to that, most of our buildings were in load-bearing brickwork and steel structures. Yes, at that time, probably we used to go for mass construction. We used to believe in masses. Now, when the mass came down, we are more prone to use of concrete. But nowadays, when we are going ahead with very tall, ultra-tall structures, and a place like Calcutta where the soil is soft, we need to shed off the dead weight of the structure. And in order to do so, probably steel is the only answer to it. And steel being as a versatile material, as you can understand, we can play probably with steel, but yes, with a caution, because the junction details and all are very important, which can cause disaster to the whole failure. But as a material, it doesn't have any lacuna. I think we guys must do the job correctly, that we must perform the joint detail perfectly. We must execute the joint detail perfectly. And of course, the designing and the selection of the sections, these are the things which we should do. But as a material, steel, I think, is the most versatile element, and there's no need to have fear in using steel. Go ahead with it, please. It's the material that you should love. And we have a lot of myths in our mind that steel is not modular, we cannot do it this way. No, we can play with steel in any form, So I'll head over to SHRIVASTAVA.
Hi, good evening, everyone. I'm PRAVEEN SHRIVASTAVA. I'm from Tata Steel. I think that defines my association with steel at least. So we have been serving the country, Tata Steel, for more than 110 years. And as you rightly mentioned, so much steel was used in this city, including the Howrah Bridge, which was supplied by Tata Steel 70, 80 years back. So I stand here or I sit here to support anyone who needs steel, who wants to celebrate steel, who wants to, as you rightly said, steel needs to be celebrated now. It's unfortunate that we are rediscovering what we did 100 years, 80 years back, and finding solutions and people who want to use steel and convincing them that steel is the right product for their structure. So I'm part of this journey with all of you and all of you sitting here.
Hi, good evening. Firstly, about myself, I'm YATINDER SURI, IIT Kharagpur alumnus, also a Distinguished Services Alumnus Awardee. After graduation, I joined Tata Motors. My father and my grandfather worked for Tata Steel. So a long association with the Tata Group and also steel for that matter. Coming to my professional side, currently I am the country head and managing director of Outokumpu India Private Limited. Outokumpu is the oldest stainless steel company in the world. In fact, our life cycle cost story started 106 years back when the metallurgical evolution began with the cutlery, which is the ferritic stainless steel. From cutlery, we have come a long way through a lot of R&D and metallurgical innovations. So many bridges, so many buildings, so many ornamental applications you will see all around the world. And stainless steel, the very name signifies it is corrosion-free, it doesn't corrode. So corrosion mitigation is also another aspect. Somebody talked about saving the planet, somebody talked about protecting the environment, somebody talked about recycling. And we fit everywhere, wherever you talk about sustainability. And we have proved it to the world that stainless steel as a metal is the cheapest metal that you can have around you. So don't get carried away by the myth that the initial cost of stainless steel is high. Yes, it is high. Somebody says, sasta roye, bar, mehanga roye, ek bar. So once you take stainless steel, the right kind of stainless steel for your project or for a given application, for hundreds of years, it's a fit and forget kind of a story. No maintenance is needed. So it's a perfect example of life cycle cost advantage in anything that you create. The tagline of my company is creating a world that lasts forever. So that's about me and my company. Thank you.
All right, thank you everybody. So I guess Mr. Suri, you kind of touched on the right topic. So we're talking about the life cycle cost today, and life cycle cost is, as we know, it's made up of three components, right? The initial cost, the maintenance cost of the structure, and then any cost associated with renovation and retrofitting of the structure as required. So I guess my first question, and the format we're going to follow is I'll kind of throw out something, and then whoever wants to jump in, we can talk about it, discuss about that. So based on these three components of life cycle cost, I mean, from your standpoint as architects or manufacturers, engineers, what do you think is the best way to kind of reduce this cost? Because at the end of the day, we're here to try to promote steel, right? So you've got an owner who wants to do a new project. So how do we sell steel? Very simple question.
See, I think I'll put it that there was a nice project that we started with. It did get complete after 7 years of working. Okay. Now, that's called BioWonder. And the challenge was that how to get steel going in the building. It had a span of 8.4 meters, and it was a staggered design to allow maximum skin area. So when we talked to the client and we said, if you make this structure, the idea was, how green can we make the structure? So we wanted to harvest the natural light. We wanted to harvest the view to increase productivity. Basically, I'm coming from a very simple thing. You see, when you see a building, the life cycle cost analysis of a steel building is not just excluded in the building, it comes from its operating costs. Within this operating cost comes the profitability of the occupation that's going to come. So there's a productivity index inside design, and there's a real estate index.
Right.
Here, that BioWonder design was explained like, if 15%, let's say anything between 12 to 15% is your rental cost and things like this, energy costs are much lesser, maybe 2 or 3%. The major bulk cost is your the salary cost when a guy occupies an office. So we converted an occupational matrix to the building matrix and justified that if you use natural light in a system, you'll increase productivity. And if you can reduce those opaque columns in the cantilever, had more view, because the usual RCC structure would have a lot of diagonal girders. A verandal girder structure which will allow only 13% of the view. We wanted 82% clear view, and hence we resorted to a steel design. So we linked up, we kind of linked the steel cost to the output cost, and showed that within 6 years of your occupation, the building will be done. Your cost of the building will be levied. You'll be clear of your costs. And your operating cost would come down by 38 to 40%. So that was the advantage of steel, and that building you can see, its office tower has been already completed. I think the couple of floors are left. It is next to Ruby Crossing. You will see that by the Fortis Hospital. Sorry? Yeah, beside Fortis. So that's a complete, and to convince the client, and this is the question, it was a difficult task because there were about 7 designs that we produced, and we were only biting on that how green and how connected to nature can we make because of the stress factor in office and people, a lot of issues. I'm not going to that part of it. But hence, when we started looking for a design, we automatically came to a design which would need a minimum number of opaque components. So the steel was the only option, augmenting the spans to 8.4 meter and having gardens in the edge. So every office has a green garden. And of course, that's a design, I think it's done. So it's only about day for yesterday we got the CC after almost like 8 years. Okay, so not 8 years of trying actually. The government is good. I'll put it like this. After 8 years of homework, the project got completed from the scratch. Of course, there were many issues. It's get the contract and all those things will come later. But yes, to convince the client in real estate, answer it by money. So if we can use a matrix of profitability in terms of occupation, the client is easy. So I try to use in that first, along with the form based, because if that's a form for function and for productivity, he understands it. So if he makes money, he'll say, okay, it's fine.
Yeah, I guess that's
very simple. It's like if money has to be put in and he's more cribbing about the capital cost, you can answer it by money itself, and that has to be explained.
right. So what you're saying is steel is not only a green material, but you have to prove to the owner how it can save him some green. Right, so,
yeah, you can get more
and then the one thing that I probably did not mention earlier is, additional to the initial and maintenance cost, is the operational cost that you were able to
that's
set.
a huge cost.
And that's where you can kind of put into the life cycle cost.
It's almost 80% and above.
Right, Aditya.
Taking a cue from what Vivek just mentioned, we are deliberating on the life cycle cost of steel. I think the easiest way to convince our clients to resort to steel is that while we talk about the life cycle cost, steel buildings are born faster. They are born faster than the conventional concrete buildings that we see. So you actually have a good-looking baby who's born faster. So I think that by itself, to any smart investor in real estate or in allied industries, the basic the basic convince comes from the fact that the time cost involved. So the turnaround time, in fact, I'm sure Vivek's project that he's just mentioned took 8 years. I would say that I'm 100% sure as friends that steel wouldn't have taken so much time. I think compliances, I think the research, I think the finding the right guy to build the entire building, response from the market, those are the stuff that takes time, not steel itself. So I think the life cycle of a steel building kicks in faster. So I think that's something that's how the world works, actually. So there are more steel buildings ongoing in the world than conventional concrete. Mm-hmm. So I think that has that logic gets derived from the fact that they are born faster.
Actually, I would like to add something more to this. It's not about convincing the client alone, because I have a different experience. Apart from this, whatever Vivek and Aditya said, sometimes it is the other way around. Like, for example, let's say you are doing a condominium project wherein you have to build an experience center. Now this experience center has to be built in maybe 2 months' time, after which the experience center, the very purpose of that experience center goes away. So there are certain occasions where, it's like it has to be done in this manner, otherwise it cannot be done. Sometimes like that. So it's the other way around sometimes. It becomes like the client himself wants steel structure to be constructed, and it's imperative that it has to be in that manner. So convincing the client sometimes is very easy in such kind of occasions where the need is to build something very fast.
So where steel is the only choice.
So the steel becomes the only choice.
So from you guys' standpoint, I mean, we'll get to the speed and all those things later, but from a overall cost standpoint, I mean, what can you add to that?
So, as he mentioned, that first of all, the cost of the time to the project time itself cuts down by half. Our little experience in steel building versus a complete conventional building, it's about 50%. So if you're going for a commercial building, it is ready that much earlier for you to use it and generate revenue out of it. Also, steel structures, if you use, he mentioned about less opaque area in that. Even if you go on high-rise buildings, the steel columns gives you more floor area than a concrete building. So that also you should add as the benefit that the
so there's more area to sell or rent or whatever.
Area to use and all that. You also mentioned about restoring recyclability of steel. Steel is the most recyclable material in the world. And if you see the structure of, the cost structure of steel, how it is going up, so whoever has made a steel building, say in year 2000, the steel prices have gone up maybe twice just now. And it's because of various cost factors. If today he has to demolish that building, and if he gets 50% of the steel that he has used on current prices, the steel that he bought 20 years back is almost free now, because he'll get that money back which is not possible in conventional buildings.
Yeah.
You have to demolish if you have to demolish a concrete building, you have to just throw the rubble out. All these things you add in the life cycle, if you're doing a life cycle analysis of a building.
Yeah, absolutely.
Yes, I'll actually respond to what you said initially, that initial cost plus maintenance. I would add inconvenience to, let's say, if the bridge is closed, then you have another cost in creating an alternate route. And then mostly it's a kacha road, and then inconvenience to people and safety issues. So there are many issues, which are not considered. All we look at is the initial cost. But if you have an initial cost which is higher, but then it needs no maintenance for the rest of its life for 100, 200 years, I think that's an excellent solution. Because no inconvenience to people, no leakages in terms of maintenance. We know if the maintenance needs to be done in any of the units, in any of the projects, how much money goes where and gets distributed among so many people, the shoddy work and things like that. So what I'm trying to say is that the learning from the recent bridge collapses in KOLKATA or in Mumbai or everywhere where corrosion appeared to be the main reason. So are we as a society, or are we as professionals sitting on this side, are going to be reactive always, or are we going to be proactive? Are we going to look for an infrastructure creation which will need no maintenance, which means no inconvenience to people, which means the lowest life cycle cost? I mean, this as a concept has to come into our minds, and we need to get committed. And having said that, let me tell you, corrosion is a menace. The recent impact study done in India by NACE confirms that 4.2% of our GDP is lost due to corrosion. And corrosion mitigation now is a national mission. Mr. Modi has created a national mission. So what he's essentially also trying to say, besides Swachh Bharat and Ujjwala Bharat, he wants India to look stainless in the sense that there should be no corrosion. India should be corrosion-free. So all of us should look for a solution which means no corrosion, no maintenance, highest level of safety. You look around, all metros, all railway coaches, they are all stainless steel now. Even buses are stainless steel. We are talking about electric vehicles made of stainless steel. We are talking of cars made of stainless steel. We are talking of high-strength stainless steel to reduce the weight of your public transportation and things like that. So what I'm trying to say is that the world is getting more and more aware of life cycle cost, protecting the environment. There is something called Earth Debt Day. So whatever the nature offers to us for consuming in a year, how quickly are we consuming it? In the 80s, we were consuming by end of December. And last year, the date was 2nd of August. So we are consuming our natural resources so aggressively that at some stage, 30, 40 years down the line, we are left with no minerals. So you have to look for sustainable materials. You have to look for sustainability. And you have to look for applications or look for designs which do not call for a lot of maintenance and things like that. That's my view on life cycle cost.
Sure. I guess you're trying to say that, I mean, there are no maintenance or maintenance-free steel, so you're referring to stainless steel. However, there's going to be a lot of places where it's not always going to be stainless steel. So we do need to think about and account for the maintenance cost. So corrosion-free Bharat, so I mean, for that, I think we'll need to think about what is it that we need to, and how is it that we need to maintain our structures. So from a structural engineering standpoint, Mr. Santra, what can you add on that?
Whatever my experience I had, and all said and done, we can do good amount of paints and etc., etc. But what I have seen that the more the steel is exposed to the environment, I am not demeaning anything about any paint system or something like that. The more they exposed to the environment, it is prone to corrosion. So in a way, I was just thinking the other day that why can't we think of something that we can take most of our structures inside? Like what I'm saying, I'm trying to, it's a very simple thing, you know, if for a commercial building, we are designing a commercial building. Of course, in industrial building, you cannot do it. But in commercial building, for example, if you can do it like this, a high-rise commercial building, that we inset the columns inside by say, 600 or 750 inside, and then we wrap around with the facade, then you know the column doesn't need any maintenance in that sort because it's not exposed to. And that too with architects down there, they would love to have the facade exposed to this thing. So that is one of my thought as a structural engineer, which we can always improve into, then implement, and which can help in maintaining the structure. As a general principle, which I was dealing with structures and all, especially I'm talking of building structures because mostly I'm handling building structures. Commercial, right now, the state that we are here, the commercial buildings, the hospitals, hotels, schools, institutions, these are much more, I would say that the steel is structured more apt to that use of the buildings. In a residential building, well, with the versatility and the speed of construction that we need to do right at this moment in the country, we do not need that speed in a residential building. So in a residential building, what my view is, better that the way that we are going, although in a high-rise building more than 50, 60 steel has to come. But in a moderately high-rise buildings, I think we better not use steel. Maybe if we are at all using it, we can embed them as a composite structure. We can, but in commercial buildings, of course, if you will get in using steel, we can go for a 15-meter span, use composite sections, which can enhance the entire floor space in a big way. You know, and with the use of composite, we can even reduce the depth of the beam, which can give you a much more flow height in a way. And again, if you go for a hospital or hotel or school buildings, its modular construction is again, all said and done, again, steel is the most versatile element in using in more modular construction. And apart from the lifestyle cost is that, and that is where we structural engineers, along with the architects and along with the manufacturers, must convince the client that yes, if this is the time frame that you need to do the project, then I think this is the material that you have to use it. If you need a 15-meter span, clear span within the column to column, there is no material without steel that you can handle. And because then otherwise it will be too heavy and you will ask me that it cannot happen because the clear force space is killing you. So that's why that is our duty to convince the client also that probably in doing this type of building, in having this kind of a speed, we probably need to go for steel. Steel is the only answer. And at the same time, we should, as a professional, we should not use just for the sake of use it. So we have to use steel in the right format and do justice to steel, because steel is meant for large span. If you use it for short span, steel is not the right material probably.
I hand over.
Very well.
All right.
I'll just add one point to
Sure.
what we said. I'll just give numbers so that we can just remember that entire thing. When we use steel, what Utpal just said, that encasing the steel with a skin system is much more viable steel construction than exposing the steel.
Sure.
We did a very clear mathematics, and I can assure you that with the best technique in terms of skin system or exposure system, if you expose the steel, you kind of treat it out. Whatever you do in our country, in the next 10 years, we will still prefer strict structures, mathematically advantageous by more than 40% advantageous to have exoskin above the steel structure. The second is the occupational fatigue, which is coming in real estate. That means initially buildings were designed for 80 years and they were residential. You lived, your grandfather also lived, and your forefathers, everybody lived in the buildings, okay. Now, those buildings having fatigue, so they want to change up. You want to make a residential, and soon after about less than 4 or 5 years, you want to change to a different apartment. The guy is changing. Someone else is coming. The life in terms of you want kids' space crashed down below, you want shops very close by, you want to change the matrix of construction, you want to change the grid of real estate. So with flexible long spans, the advantage that you get is a grid change, and that gives the more usable, viable life to the building. So steel is actually enhancing the flexible occupational, which you call as an occupational fatigue. It removes the occupational fatigues and gives a very big viable life to real estate today. So which we actually couldn't be able to do it in any RCC or a simple.
Right, that's the renovation retrofitting part, where the reuse of the building for some other function, change it.
And it's becoming very, very common in all of the places. We will soon evolve to only mixed use design. Soon architecture and structure will only talk about
Mixed use.
mixed use. Even hospital ke niche mein you'll find, there's no harm in saying there'll be a hotel and a hospital in the same grid, which exists also.
Yes. Okay, so I want to go back to something, Aditya, that you said earlier, and some of you guys talked about as so. One of the things that we always think about steel is, and when you're talking about overall cost, is the speed of construction, and you mentioned it could be as much as 50%. So I want to talk about making it a little controversial. Is it really in real life? Are we getting that actual speed of construction? So actually when you start construction to when you finish it, maybe yes, it is 50%. But are there other challenges that you guys have during your project's life, have seen that maybe it's the fabrication or some other things which, or the availability of material, which is kind of reducing that that beneficial factor of speed of construction, and then maybe it's not 50% anymore, maybe it's 80% or something like that. So what are these other challenges which we as a community need to work on to make steel a really fast option to construction?
Abhijit is really thrown in a bomb here. I think when we were talking all lovey-dovey things about steel, steel per se in construction is still, it has, according to mass perception, it still has a snob value. Talk about large projects. Me and Vivek were talking about a project that he just mentioned, that you actually, after post-design, the main challenge becomes availability in a city like Calcutta. You're talking about a metropolitan city, and he had to wait for months to find out the right guy to do the building. In fact, I just mentioned that forget a metropolitan city. I think availability is a major issue. Not only availability, finding the right kind of fabricators, finding the right kind of, a turnkey contractor is very challenging in tier 2 and tier 3 cities today, even today. And I think that is one hindrance that kind of puts, it kills design ideas and steel ideas on the table itself, especially with clients who are, like he just mentioned, that it took him 8 years. To a client, if we are trying to convince him on the time less taken by steel, client would any which way say that compliances would take that much time, so why don't we go for conventional construction? So I think he has to be convinced from from the perspective of the right logic. His visibility, the permeability of the facade is a better sales pitch by an architect than trying to convince the client on availability and speed. Because I really have, I think, an issue with availability of steel across the nation. Especially, we are currently working, apart from Chennai, we are working in all the metropolitan cities. But I think in the tier 2 and tier 3 cities in rural India, steel is still a, it's kind of, it's a snob thing to talk about, because what India wants to do currently is, it just wants to build. It just wants to build without having to worry about finding the right guy to build for you. Half of India would actually build it themselves. So I think that's a huge thing that the steel industry, including us, needs to really reflect upon, that we need to make ourselves more available. And especially in projects, I mean, just taking a bit of time, in projects which are not that large, there, I think, comes the main challenge, because finding the right guy for projects which are smallish, we are talking about celebrating steel. But why to always celebrate steel in large projects? I mean, we can actually celebrate steel in a very boutique fashion. We can actually talk about doing things in interiors, in things that just stand out as a boutique piece, make it look like sculpture. But I'm really apprehensive that we'll get such right people. I mean, I'm doing a project in Ayodhya Hills that we are actually talking about. So I'm happy that I've connected to a friend, and I'd probably have it built by a friend. But otherwise, I really shudder to think on the client's woes on finding the right guy.
All right, so I guess I want to, so how do you respond to that? I mean, how are companies like you working to make steel more available? And
so I would like to draw a parallel here from the automotive industry. There's something called EBI. So when automotive companies plan to launch a new car, which is like 3 to 4 years before it is actually launched, they are on the drawing board. And they involve their vendors, whether it is steel supplier or engine supplier or even tire manufacturer, that this is what we are designing, and whether we will be able to jointly work with us. And 3 to 4 years is a good time in automotive to work and develop those steel and those specifications that they want. And I would urge, and we have done that in in small numbers, but in large projects. We have worked with architects, and we still call it EVI, where when you are designing and conceiving a project, if we are involved at that point of time, we will ensure two things. We will ensure that the cost comes down, that appropriate amount of steel goes into it, and we'll also ensure that availability of steel is there when the project comes up. But this is for large projects. I take your point for smaller projects. It's not possible to do with smaller project this EVI kind of thing, but the onus is on us to develop an ecosystem of this so-called fabricators or people who are going to execute your designs. So
in smaller projects, I just mentioned smaller projects because of the fact that I just faced it myself, that in smaller projects, when we are wanting it to do it in steel, at times, I'm not necessarily saying it happens all the time, but at times we make the client feel too small. So, and that's not the right way to deal with
not that. I
no,
mean,
not particularly with your response, but I'm talking about the market on a larger scale, that when the client feels that mera project to bahut bada nahi hai, and then he doesn't get a response, then I don't think we are kind of having the ecosystem that should exist. Because the more invasive steel becomes into medium and small scale projects, I think our panel discussion is successful.
No, so I was talking about time from design to execution, how to bridge that gap of design to execution. So availability point of view, I can assure that as steel companies, Tata Steel or any of my competitors also, we have ensured that steel is available at least in all the tier 2, tier 3 cities, and we have a network which we can take to all the rural areas also. I think Chandrama spoke about building nesting in remote areas of the country. She just took 2 or 3 examples. But I know she has gone into interiors of Odisha and Jammu and Kashmir, she mentioned. So we ensure that steel is available. But I take your point to match your specification.
In fact, a point addition to that, I think what we as a practice we want to do, we are currently trying to do is to request our structural consultants to design in available sections, not for built-up sections. Because available section, when we are talking about, interestingly, about the life cycle cost, then actually if we are able to do our designs in available sections, then we are actually reusing steel even after the building is dead. So we are talking about life after death. So that reusability is ensured if we are able to design in terms of available sections than having bespoke built-up sections which are very specific. So
you will be able to design only when you know what is available. So I think we need to work.
Yeah. And it's the
steel community and the architect.
Right, it's the chicken or the egg problem. The more we use, the more they will have and the more sections they will have. And then we'll kind of move towards a more mature market. All right, I guess, I mean, we have to be done by 5. So I want to definitely leave some time for questions from everybody in the audience. Before we do that, I just want to touch on 2 quick things, and whoever wants to jump in. I guess one thing I wanted to bring up is, I mean, yeah, we as a community sitting here, we do all want to use steel, and I'm sure there's clients who want to use steel. But from your standpoint, what have you faced? I mean, are there challenges when you're trying to convince a client that these are the reasons we want to use steel? Sometimes it may be the other way around. Client wants to use steel, but there's some challenges like we talked about. So how do you kind of manage that client aspect with it? I mean,
I'll make it smaller. And one thing I just want to say, and here I want to really appreciate the SSMB team. Just mentioned. Yeah. It was just 1 year back that we were actually working on together for a project which is like for a large span structures, and it's a tall building in steel. So what would happen is we met Tata Steel representative. We met Mr. Murli here, right in this conference, and we sat there and we jolted a time schedule in our office for a brainstorming. And from there, we actually participated them into the drawing board with Dada, Utpal Santra, together to evolve a sensible steel structure design optimized faster and everything. And that is what he's trying to say, that if you work on the drawing board stage, rather than isolating the design and then coming down, that's very, and this is the credit given to SSMB Steel Company. I think they deserve this little clap. I'm really happy that, you know, such a small session they do it very well and very concentrated here. And it's really productive. So I am the witness to show that it really worked. This thing really worked, and it really worked what he's saying. As far as
just to add this, I would say that with Murli, in fact, the meeting that Vivek was telling, we saved about 15% of the total steel consumption, you know, because the main steel columns, if we are going for a standard section, it was coming out to so heavy. Then we discussed with Murli that we need this IXX and IYY. So can you manufacture this thing? And he came out with the solution, and hats off to him.
Made to order steel.
Made to order steel. Another small thing which I was Aditya was mentioning, and this thing is that, you know, again, we should design everything to its merit. For example, in a small project like this, in a small project, we have, as a structural engineers, we have the duty to design a structure which should not be very complicated. It should be very simple to construct. We should not get into too much of fabrication. We should not do any very complicated connection details. It has to be very simple, so that, you know, even a guy there who can just bolt it down there with the flange connections. That's the most easiest. That's what we should do always. That do as per the requirement. Never get into complicated details. But in large projects, large structures where contractors and fabricators are good, yes, you go for as you can go for complicated connection details. And again, the confidence of that fabricator has to be with us as a structural engineer, so that we, in the back of our mind, we should not think that we should need another stiffener plate, we should need another bolt to, the fabricator will miss it out probably, so add another, and then we come up with a huge bunch of bolts and nuts and stiffener plates. So that is one thing that the fabricators also have to come up with to the designers, that yes, we can make it, you do the design, we can make it. So that is the thing that we are facing. Yes, of course, a lot of things has been sorted out, but I think something which we should also work with Tata as well as other manufacturers, that, and as well as the fabricators, sit together at the table, that yes, I need this detail, can you make it?
So as we are maturing as a community, I think everybody coming together plays an important role in that. I'm afraid I think we are getting close to the end of our time. So at this time, I guess I wanted to open it up to any questions from the audience, and if we can have a mic.
This is.
Can you get them?
It is very heartening to see so much of a positive response for steel structures. But from the discussions, whatever we are having so far, I see it is primarily for these constructions which are coming in the private sector. That is, iconic buildings are coming up where a lot of steel is being used. How can this particular group, or particularly I'm looking at all the designers and architects, to influence the government to go in for large public projects also with steel structures?
Here, I just want to add to you, we are doing, you are based out of Kolkata?
I am based at Kolkata only.
So there's a project that we're doing, it's a trade fair ground and a convention, it's called Milan Mela, where the spans are 120 meters. So there, initially we were doing different structure and different thing, but like we resolved to about 80% in steel, and we could convince them, and they got convinced about it.
That is all with big spans. Like let us say for this Calcutta, we have lot of flyovers, road over bridges with steel deck.
Yes.
But once you go out of Calcutta, any of the NHI projects, you rarely you find any bridges coming with a steel deck there. It is all reinforcement concrete only. That way, amongst the various metros, Calcutta has got a very good acceptance of steel. Whereas if you go to other metros or the other major cities, you really don't find that much of acceptance of steel. I'm just making this statement, ki how we can really improve upon. This is one question. Then second was one issue which was raised about built-up sections and ready sections kind of a thing. I am from Steel Authority of India. So we do have now a very long range of ready sections with new mills coming up. And still we find that there is a lot of a gap between what we can offer and what finally the design has been made. Maybe we have to find a way out to bridge this gap at the design stage, getting involved and see that how the ready-built sections can be used, which will in fact make it much faster. In case of built-up sections, again, I am the only major supplier. Plates which are used in the built-up sections, SAIL has got a 50% market share which goes into the built-up sections. But in spite of that, in order to increase the steel usage and also to speed up construction, the ready-rolled sections which are available, if they also can be designed in the design stage itself, maybe your construction can be much faster there.
Agreed.
Absolutely. One thing about the government projects I was going to say, I mean, we do see that, I agree with you, there is a lot of bridges that are in concrete, but things are changing. I think in the last 4 or 5 years, I hope the people will agree.
I have good news for you. I think, like him, we are working for the state government of West Bengal. In fact, government acceptance for steel, I think, is and should be faster in terms of development, because steel is faster. Politicians understand time like none other. I mean, they understand time because they have to fight elections every 5 years. So projects can be completed with steel. So there's an acceptance in the government, I can tell you, because I'm personally working on projects which are non-very large spans. So that's one. Secondly, it's very heartening to see, I think, to my city mates here, when we are going out of the city on Konai Expressway, you actually find a beautiful terminal building coming out of Satragachi railway station, which is NK Steel, which is large and which is by the railways. So I think, yeah, there's acceptance, there's growing acceptance of steel in a way. But I think the point that I mentioned about built-up sections vis-a-vis available sections, that is something I think which is, we have to, the AEC professionals have to take it up as a challenge, so that there's a kind of, streamlining, because at times built-up sections, etc., that makes things complicated, especially in mid-scale projects. In large-scale projects, everything is acceptable because people are aware and you need large spans, etc. But in smaller projects and mid-scale projects, I think the need of the hour is to do with whatever is available.
All right, one last question, because I think we're out of time.
1 minute. This is regarding one clarification to Mr. Aditya. You were telling about rural and Tier 2, Tier 3 cities availability. If you see the existing system, all TMT reinforcement bars are available. You go to any corner in the country, they will get. The reason being, when the usage is there, the product availability will come.
Right, we talk.
That's why from steel manufacturing point of view, or as a manufacturer, there is a gap between know-how of how to design, how to use steel from the college itself and practicing engineer itself. A guy in Durgapur, being a civil engineer, he knows how to design a 2-story building in RCC. If you ask him to design a beam of some 20 feet, he may not be knowing. If he doesn't know that stock or a retailer, he will not keep a ISMB 200. That is the gap. That's why what we are trying to do is, from Tata Steel, always we believe in knowledge sharing and sit with all stakeholders, and we are trying our part in a small way across the country. That's why what the help we need is the support from AEC community. We are with, for steel manufacturing, are bringing the new construction technologies and products. But end of the day, it depends on architect, structural engineer and fabricator.
All right.
That is the request. We have to dependent on you.
All right, so sorry to cut you off. He's been waiting for a long time. We'll take one really last question and call it a day.
Actually, thanks to this organizer of this conference, and I'm very much delighted to present here. Actually, I was in dilemma whether I could attend this conference or not, but I am very happy to attend this conference. And also, I am very delighted to listen to the discussion. Just one example I'm giving. I was very enthusiastic to get information that a big school building was made in outskirts of Calcutta, near Pailan or somewhere. That is a composite building. And some people informed me that is a composite building. So some of my relatives, children were there. So I went to the school and I met the principal or owner of the school eventually. He told me, I told him, thanks, you have made a big building, 6-storied building with steel. But response is, hum mar gaya. Why? What is the problem? Well, a building, I cannot make this building, it is a completely reversible type. You can see in the classroom, just side of the classroom, there is a big bracing system. You can see in the inside somewhere there is a bracing. So, and he told me, actually you discussed this also, say what I understand, the owner is saying, that if I go for the concrete, time, just sometimes could be extra, but what they did with this building, paisa zyada kharch hua, kyunki jab concrete encasing was there, so inside the concrete, they have given much more steel than the reinforcement. This is his belief. So, why I'm giving this example? Actually, first, what Mr. Murali was trying to say, that we, the structural engineer, should, as a practicing engineer, we require more exposure to the actual and economic design of steel structure. Yeah. You will be, everyone know that our code, latest code, steel code, is 800/2007. After 26 years, code has been revised. It's for information. Last code is 84, and then 2007. You can understand our development of steel. So this code in 27, I am telling you that it is not being implemented properly at designers levels till today, after 12 years of publication. This is a limited state code, and so I'm telling you, the bracing system I told you. Actually, we have to take the building with a moment connection. That is, there is no bracing in the building. No bracing system should be there. If no bracing should be there, then the fabrication quality much more higher, because it's all the non-sway frame and all the connection will be the moment connection. So these are the problems is there. But problem starts from home. That is why I am self-criticizing me, that we are not very conversant with steel design basically. And the government body and the manufacturer also not guiding us properly to do this design. So it requires guideline so that the practicing new young engineers can interested in steel design and they can perform it properly.
I agree. Thank you for those comments. I guess we all agree that there is a lot more needs to be done in form of education, and so the newer engineers coming up, they'll be more conversant with steel. However, we've come a long way, and I think steel is here to stay, and we should all keep promoting that. Thank you to Avneet and the team. I think I see Carol here, so thank you for being patient. Thank you for all the panelists. Yes.
Sorry to bother you. I'm Das Gupta from UCAM. I thank you all for promoting still. I've got a few observations. One of my delegates has told that use of steel in government sector is not finding. But rightly Mr. Rathore told, beside Miran Mela, you find 2,400 seaters in Alipur. It's the government of West Bengal project by NBCC. There, inside entire structure is steel. Whether it's column or beam, everything is steel. So, and secondly, someone said that in Calcutta, the acceptability of steel is there in metro. In other cities, it is not there. I totally disagree. Because in country-wise, we are doing steel fireproofing business. The steel fireproofing business is very, very poor in Calcutta. Rather, in other metros like your Bangalore, Chennai, Gurgaon, Delhi, Mumbai, it is flooded. And I personally thank Mr. Rathore, who mainly promoted, one of the main person who promoted steel building in Calcutta. By wonder, the pictures are with me. It's a wonderful design he made, and the entire Bywonder steel G+20, I believe, Mr. Rathore, was fireproofing done by us. So the steel is coming. But in Eastern India, it's not that fast, but in other metros, it's very common. Thank you, gentlemen.
Thank you. Yes.
Thank you all. It was indeed a high-intensity knowledge sharing day.